At this time, I would like to welcome everyone to the SES-8 Falcon 9 Geotransfer Mission Conference Call. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question-and-answer session. If you would like to ask a question during that time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. I would now like to turn the call over to our speakers, Gwen Shotwell, President and COO of SpaceX, Martin Hallowell, CTO of SES, and Elon Musk, CEO and Chief Designer of SpaceX. You may begin your conference.
I'd be happy to answer a few questions, and then I'll drop off the line, and Gwen can take it from there.
Okay, conference host, can you please pick the first reporter with questions?
Certainly, ma'am. I'd like to remind our listeners, in order to pose a question, please press star 1 on the telephone keypad at this time. It will take just a moment to compile the Q&A roster. It will be just another moment for our first question. Our first question comes from the line of Tariq Malik with Space.com.
Hello, Elon. Thank you so much for having this teleconference today. It's Tariq Malik. And I guess my first question would be, what types of modifications that you've made that make you more confident on the second stage restart for this flight, and how this capability really will be a tool for SpaceX in terms of both Dragon and now satellite launches out of Florida. Thank you.
Sure. So, on the last flight, everything worked really well. I think we were able to retire an enormous amount of risk with the new design of Falcon 9, with one exception being the restart, which that's why we find that. Aim for that mission to deploy the satellites on a single burn insertion. For this mission, obviously, the second burn has to work in order for it to be successful. Our analysis of the prior flight, and this is SES agrees with this, is that the igniter lines, the igniter fluid lines froze due to liquid oxygen bleed impingement on those lines. So we've increased we've had a lot of insulation to those lines, and then made sure that the cold oxygen doesn't impinge on those lines, and that seems to have. We believe that will address the restart issue. I should still view this launch with, from the perspective of it. There's still a fair bit of remaining risk because this is only the second flight of the new design of Falcon 9. And even rockets that have been flying for a long time, like the Proton, still have failures. I think there's been something like 4 failures of the Proton in the last few years. So, with rockets, there's always some irreducible risk. But I feel like the one thing I can feel comfortable about is that we've done everything we can possibly think of to maximize the reliability of this launch. So there's no stone that hasn't been turned over at least twice to maximize the probability of success. Still leaves us with being a rocket, some chance of failure, but whatever happens, I think we can be at peace that we've done everything we could think of, and SES's technical team has looked at it and they concur. So the rest will be up to fate. So. And then with respect to the future potential for the rocket, I do think I'm really happy with this rocket design. It's an incredibly capable vehicle. It's actually one of the biggest rockets in the world. It's worth noting. At about 1.3 million pounds of thrust, and we're only actually operating the engines at about 85% of their potential. So down the road, future missions, we anticipate being able to crank them up to their full thrust capability of which would give about 165,000 pounds of sea level thrust per engine. Anyway, so it really is something that is I think it's going to serve very well for the commercial launch market, certainly for government satellites and for Dragon, both crew and cargo. Yeah, I think it has. I believe its inherent reliability potential is better than any other rocket in the world. And so it'll be up to us to ensure that it lives up to that reliability potential.
Maybe from the SES point of view, maybe just join into a couple of comments that Elon's made there, and maybe focusing a little bit about the second stage restart anomaly that we saw on the Cassiope mission. We've worked extremely closely with the SpaceX people, both in Hawthorne and also here actually on the pad down in Canaveral, to see exactly what's been done. We're very, very confident. We understand exactly what the issue was. We understand the mitigation that's been in place there, and we are fully confident that all the risk from that particular element has been retired, and we're ready to go with the launch. We are confident that we have a good launch vehicle here, and we're ready to launch.
Okay, our next question comes from the line of John Amos with BBC News.
Hi, thanks very much for doing this. Maybe it's a question I could put to Martin here. What does it mean to have a new player in this market of flights going to geostationary? What does it mean for you and the other satellite operators to have another choice?
Let me put this very, very clearly and maybe not too dramatically. The entry of SpaceX into the commercial market is a game changer. It's going to really shape the industry to its roots. We're very excited to be part of this. That's really why we have pioneered the first launch here, the commercial launch with SpaceX. The whole interface with the SpaceX organization, with the launch vehicle itself, with its capabilities now and for the future, we see this as being a very cost-effective and very accessible way to get our satellites to orbit. We think this is the way to go forward for the future. We have this launch. This is our 55th launch, so we know a little bit about launching satellites. That's why we react so positively to this. And after this, we have 3 more options together with SpaceX. So we see these guys as a very key player. I think all the other launch vehicle providers are looking at great interest in the success or not of this launch. And I think that they will be very, very interested and rather worried, for their future and how they organize themselves and their industrial processes to be competitive in the commercial launch market for the future.
And Gwyn or Elon, do you have a message for Arianespace, ILS, Sea Launch?
Well, I mean, I think the organizations make good rockets, but I think with the advent of Falcon 9, we're hopefully going to provide a forcing function for increased competitiveness in the launch vehicle industry, and essentially provide a good forcing function for improving the technology across the board. Because unless the rocket makers improve their technology rapidly, that they will lose significant market share to the Falcon 9. And I actually think it's a good thing if there are multiple providers of launch. So this is not some competitive provider it's really that they are going to need to improve their rocket technology, and in order to compete. And I think that's going to be a good thing for the future of space.
Competition is great for organizations. It keeps them sharp, it keeps people motivated. So this is all a good thing. They may not look at it that way, but hopefully they come appreciate it in the future.
And if you achieve the flight rate that you hope with 10 Merlins on a rocket, I mean, can you maintain the quality to do that? That's a lot of gear.
Actually,
yeah, I think so. Sorry, can you hear me okay?
Yeah, go ahead, Elon.
Yeah, sorry, I think, Gordon, you're probably going to give the same answer that I was, which is that the higher the production rate of engines, the better the quality, because you're able to iron out lots of different things. In fact, the flight history we gain with each mission is an order of magnitude greater than a rocket that is only flying one of a particular type of engine per flight. So, having flown, for example, the last flight of the Falcon 9 1.1, we effectively got 10 missions worth of flight data on the Merlin engine because there were 10. So you get a much better statistical reliability, much faster, and you see issues with an engine at an order of magnitude greater pace than you would otherwise. And then of course, because the Falcon 9 has the ability to complete its mission even if it loses an engine, and in fact on this mission, I should mention we actually are sacrificing the ability to recover the first stage in order to maximize the performance margin for the SES satellite. And SES was kind enough to say, hey, look, if we wanted to try to bring the stage back, they would support that. So it's really to their credit, and we really appreciate that. But just to be super sure that even if there's an engine out or multiple engines out, just to be sure that we can complete the mission with the maximum amount of likelihood, we actually will not be trying to recover the stage. We're going to gather data on the stage, the boost stage, as it re-enters, and apply that information to future launches. But we're not going to try to recover it in order to give maximum performance margin to this mission. So I think having that engine out capability is a fundamental reliability improvement compared to other vehicles out there.
Thank you from London.
Okay, I'd like to take a moment now to thank you, Mr. Musk, for your time. We understand that you are visiting with your children. We do thank you for your time and invite you to disconnect at any time as I turn the conference over back now to Ms. Shotwell and Mr. Howell to finish answering questions. The next of which comes from the line of Veronica Megan with VS Satellite Magazine.
Hi, thanks again for answering all these questions. My question would be for SpaceX. What are your main capital expenditure plans for I don't know, the next 2 years, and what technology capabilities are you looking to invest in particular that would affect the commercial satellite launch market?
Well, over the next 2 years, obviously I'm not going to give super detailed answers, but I can give you some high-level information. We're certainly looking to continue to fill out the number of launch sites that we have. They're quite expensive, and we'll be focusing resources on that. We want to make sure that launch pads and launch decks are not the reason for any delay in executing our manifest. We're also continuing to invest heavily, and we have been investing heavily for the last year and a half or so in production capability to be able to ramp up from right now we're at about a vehicle per month production rate. We'll be at 18 per year in the next couple of quarters, and then by the end of next year we'll be at a rate of 24 a year or 2 a month. So those are the primary areas that we're focused on right now.
Great, thank you.
Okay, we continue now to the line of Peter DeSelding with Space News.
Yes, thank you. 2 questions. First for Gwynn. On the anomaly on the restart of the upper stage on the September 29 mission, was what diverged from what should have happened was the fact that you hadn't tested this at the temperatures that it actually encountered, or was the oxygen bleed more proximate to the igniter lines than you had thought, or maybe there was something else there that I'm missing? And for Martin, sorry, go ahead.
Sure. Let me take this quickly. It had mostly to do with the fact that the ambient temperature conditions of demonstrating this capability on the ground basically masked the temperatures that we saw in orbit. So it's not that we didn't test the entire mission profile on that engine. It's just that the ambient temperatures basically kind of masked the issue.
Okay. And if I could ask one to Martin and Holly. Well, Martin, you mentioned a couple of minutes ago how much you believe in what SpaceX can do to the competitive landscape. On this business of the upper stage, to people who've been following your company, the fact that they didn't actually perform the way they were supposed to on September 29, and you're going forward anyway, suggests you've got an unusual level of confidence in what's going on there. Is that a fair characterization?
Yeah, Peter, I think it is a fair characterization. The reason for that is that in this particular instance, we've had extraordinary access to the analysis work that's been done, the engineering work that's been done on the upper stage, the mitigation elements, et cetera, the work that's been done, the installation of the mitigating factors. We've had our crews actually crawling all around the engine space. They've been embedded together with the SpaceX propulsion team. And to that end, that's been able to retire an awful lot of the risk associated with this, and it's given us a feel-good factor.
Okay, so there's been no ITAR-related stuff that has put up a burqa between you and what you're able to learn about the rocket? What
we've done, Peter, for this particular instance is that we have U.S. citizens who are able to work absolutely hand in hand together with our colleagues in SpaceX. That information, the specifics of the rework, have not been extended towards the non-U.S. citizens, of course, but they have been able to indicate to us that basically we're good to go.
Very good. Thanks.
Peter, we also had other organizations such as NASA and the Air Force take a look at what we were doing here. They're obviously keenly interested they were keenly interested in us coming to resolution quickly and us getting back to flight.
Okay, thanks.
Okay, we continue to our next question, which comes from the line of Marcia Smith with Space Policy Online.
Thank you so much. I'm curious, Mr. Hallowell, you're using such superlatives and talking about a launch that hasn't happened yet, and of course things can always go wrong. But I'm curious about why you call SpaceX a game changer. Is it merely because the cost is less, or are there other factors that make SpaceX so different from the other launch services providers?
It's multiple different factors associated with this. Obviously, the cost is a major issue to us. We're a commercial operator, and obviously the business case associated with the satellites that we launch, a major part of that is the launch itself. So yes, that is important. And the fact that SpaceX can be so cost competitive to give us the same level of performance as other launch vehicle providers is important to us. What's also important to us is to have the close relationship with the launch vehicle provider. For us, the launch and the early operations is extremely important. It's probably the riskiest part of the entire mission. We have a lot at stake. We've invested an awful lot in our spacecraft. Our customers are waiting for this. We have revenue streams which are waiting for this. And to have that close, should we say, intimate relationship with our various different launch providers is extremely important. And that's something which we've managed to develop together with SpaceX. To a greater extent, I would even say, than potentially with our existing launch providers.
Okay. Thank you.
Okay, we continue now to the line of Jeff Faust with the Space Tribute.
Hi, Jeff Faust with Space Review with a question for Gwynn. For this launch, you're using a very high super synchronous transfer orbit, 80,000 kilometers is the apogee. I wonder if you could talk a little bit about the selection of this particular orbit and if there are any challenges in terms of using that orbit in early spacecraft operations.
Well, I'll leave the spacecraft operations piece to Martin, but I can tell you that we'd worked very, very closely with SES to craft an orbit that was fit well with the Falcon 9 capabilities, as well as deliver their approximately 3.2 metric ton payload to a useful orbit. So yeah, the apogee is high. TICOM actually goes slightly higher. But SES's inclination is a little bit lower at about 20.5 degrees. So, I mean, in summary, we worked closely with SES to come up with a mission profile and a trajectory that was very well suited for both the satellite as well as the launcher.
Yeah, from SES's point of view, the supersynchronous transfer orbit is not an unusual injection for us. Basically, for this particular satellite and this particular mission, it's very interesting for us to have the increased apogee altitude. It allows us to reduce our fuel usage as we actually decrease the inclination as we go forward with the various different liquid apogee engine burns. It allows us to optimize the fuel usage on the satellite, and it allows us to maximize our on-orbit station-keeping fuel lifetime for the remainder of the mission. So this is nothing unusual. We've done it many, many times before, and we're completely comfortable with it.
Thank you.
Okay, I'd like to remind everyone listening, in order to pose a question or comment at this time, please press star one on the telephone keypad. Again, that's star one with any questions or comments. Okay, we continue now to a question from Irene Klotz with Reuters.
Hi, thanks very much. Gwen, I have a question. If you could maybe just clarify something Elon had mentioned earlier today. As far as the DoD entrant requirements to have 3 successful launches in a row, I wasn't really clear when the clock on that starts, if it was 3 from the upgraded Falcon, and if so, did the test launch in Vandenberg count as one or not because of the upper stage issue? Thanks.
Sure, Irene. Let me clarify a little bit. We have to have 3 successful flights to get through the certification process for the Air Force and the EELV program. Only 2 have to be sequential. Regardless, obviously, we're going for mission success on all our flights. In addition, the first flight. So the requirement is to have mission success, and the first flight of this upgraded Falcon 9 was a complete success. We hit a bullseye orbit, and all satellites were released into the location they wanted to be in. So the first one counted, certainly according to our agreement with the Air Force. I don't think the Air Force has commented formally on that. But the clock started with Flight 6 from our perspective. The first 5 flights of Falcon 9 did not count towards certification, although obviously it gave all our customers a lot of confidence in the team's capability to design robust rockets and fly them successfully.
Thanks, Gwen.
Mm-hmm.
Hi, it's just Martin one more time. I'd just like to add something to the previous question associated with why we think SpaceX is such an interesting launch vehicle provider for us with the opportunities, etc. One of the things that I should have mentioned is that we very much believe in the development of electrical propulsion for our satellites for the future. And the beauty of the electrical propulsion solution is that it allows us to either launch fully capable satellites with a lower mass, which makes them absolutely suitable for a launch vehicle like SpaceX, or it allows us to be able to utilize the full mass of the satellite, but instead of actually launching chemical fuel to actually make our final orbit, we can actually put an awful lot more equipment on board the satellite, more antennas, more processing, more transponders, etc., etc. So to that end, SpaceX offers us a very, very interesting and cost-effective platform to be able to launch a far more capable satellite, which is actually going to have a lower mass due to the fact that we are flying electrical propulsion rather than a conventional chemical propulsion. I just wanted to put that together. I rather forgot that in the previous response. I apologize.
Okay, we'll move now to the line of Douglas Major with Parabolic Art.
Hi, thanks. Couple questions. One, did you ever refire the second stage in the Falcon 9 before September? And what were the results? Did this problem come up previously on the Merlin 1C? And also, I'm wondering if SpaceX is at all interested in the DARPA XS-1 program.
Hey, Doug. We might have seen some indication. Well, the configuration on the 1C and the plumbing on the back end was different. I don't want to speak out of turn. We clearly did not see this exact issue. Otherwise, we would have addressed it prior. So so I can do a follow-up separately just to make sure that I'm accurate here. We did not see what we saw in September. We have restarted the second stage on orbit on the previous versions of previous version of Falcon 9. And clearly we had been ground testing the upgraded system extensively, going through many full mission profiles. So it was not a complicated issue to fix. Obviously, we were glad we caught it on a mission where we were only demonstrating that second burn as opposed to one where we have to get it done.
Okay. And the other question was the XS-1 DARPA program that was just announced.
I prefer to focus on this mission generally, Doug. We haven't decided yet how we're going to approach that program.
Okay. Thank you very much.
Thanks.
All right, and we move now to our last question, which is from the line of Charles Lorio with Velorio Report.
Yeah, hi there. Glenn, you were talking about the ambient conditions of the ground masking the issue that had occurred on the last flight with the restart. So I presume the point of what that means is in the testing on the ground you had bleed off, etc. But once you had the LOX bleed off, but once when you're in orbit with the ambient radiant cooling of the lines, that plus the bleed off was the thing that caused the freeze-up.
Yeah, I just want to be super careful about ITAR. I've got the statement that the State Department approved right in front of me. How about if you and I don't want to go to jail. I love my family.
All right, I'll concede you that.
All right, let's talk separately, and I can share with you more details. Obviously, you can't publish them, or then you go to jail.
Okay, but yeah, I don't want that either. All right, thank you. Anyway.
Thanks, Charles.
Okay, we have now reached the allotted amount of time for questions. I'd like to turn it back over to Ms. Shotwell and Mr. Hallowell for any closing or concluding remarks.
Yeah, Martin, if you don't mind, I'll let you do the final wrap, but I'd love to say a couple of things. First of all, I obviously want to thank SES. They were clearly pioneers when they started working with SpaceX to execute this and other missions. So we're obviously extremely grateful to them to be the first flight of a commercial GTO mission. I also want to thank my team. We've got 3,500 folks focused on this and related activities, and they've been working really, really hard trying to uncover any and all issues that we possibly can, basically do our very best work before we attempt this flight tomorrow. Hopefully, obviously, for the customers and for my 3,500 employees or so, that work has paid off, and we put SES-8 where she wants to go. But I do appreciate the opportunity to do this. Obviously, we're thrilled to be entering into this market. And just the final thank you to the SpaceX staff, who, as always, works incredibly hard and is just awesome.
Thanks, Gwen. Okay, maybe a couple of words from myself regarding SES. We are extremely excited to be here. We're extremely excited to be the first commercial customer on SpaceX. We were here, I wouldn't say here, but in 1996 we were the first commercial customer on Proton, so we understand the various different risks associated with this, and we understand the impact that this is going to have on the commercial satellite world, basically. I would say, and it's not really an understatement, is the entire commercial space flight world is looking tomorrow to see the success of this flight. And it is going to change the industry. It's going to make things different. It's going to make people sit up and look, and it's going to open new opportunities as we move forward. For us, for our SES-8 satellite, it's very important. We're heading towards one of our major growth markets in India. The success of this mission is extremely important to us. We're going to 95 degrees east. We'll be basically driving DTH into India and to DTH support into Indochina, Vietnam, etc., and the whole of the Southeast Asia region. This is a big deal for us, and it's extremely important. It's a key part of our strategy for the future. And we just want to look forward to a successful launch, and we'll move on. We have 2 more launches lined up in early next year. We will have our launch of our Astra 5B satellite going to 31.5 degrees east. Then we'll have our 2G satellite, Astra 2G satellite, which will be going to 28.2 degrees east. And that will end the current phase of our satellite launches as we look forward. So yeah, for us, it's not quite business as usual, but we're calm, we're relaxed, and we're excited that we're going to have a good day tomorrow. So thanks very much, and thanks very much to our SpaceX colleagues. And thanks very much to my SES colleagues, and we've kind of forgotten the orbital guys as well, who have been really working hard to prepare this spacecraft ready for launch. They've been working right the way through the entire preparation process. We're in battery charging right now. We have around about 13 hours to go with battery charging, and then we're ready to go. So hey, let's go. Thanks, Gwyn.
Thanks, Martin.
And thank you, ladies and gentlemen, for your participation. This concludes the SES-8 Falcon 9 Geotransfer Mission Conference call. You may now disconnect.
Do you want to listen to another encore conference? Press 1 for yes or 2 for no.